students, today's lesson is on using similar triangles. So to start with, let's go ahead and look at this key idea. When two angles in one triangle are congruent to two angles in another triangle, that tells us that the third angles are also congruent and that therefore the triangles are similar. We know that the three angles of a triangle add up to 180 degrees. So if we can prove what two of them are and that the two are congruent, we can prove that the third one is congruent. So let's go ahead and look at this first example. We need to determine whether the triangles are similar. So we can look at this first example and we see, whoa. All right. We see that each triangle has a 75-degree angle, and we see that each triangle has a 50-degree angle. So therefore, X and Y are also congruent, and yes, they are similar. And we're going to say, yes, there are two pairs of congruent angles. All right, let's look at the second example. We see that each triangle has one 63-degree angle. This triangle has a 54-degree angle, and this triangle has another 63-degree angle. So we need to figure out if there's one more angle in common here. So let's solve for X, and let's do that by setting up an equation. We're going to say X plus 63 plus 54 equals 180, and we'll solve for X. So we'll combine our like terms. We get X plus 117 equals 180. We'll subtract 117 from both sides, and we get X equals, let's see, that would be 63. Okay, so if X is 63, then yes, we do have another pair of congruent angles, and therefore they are similar based on the same reasoning here. There are two pairs of congruent angles. All right, let's look at our third example. Here we have two right angles, so we know that pair is congruent. Here we have a 42-degree angle and a 38-degree angle. We need to decide if X is 38 or if Y is 42, and either way that will prove that our angles are congruent. So let's solve for X. We'll do 90 plus 42 plus X equals 180. We'll combine our like terms. 132 plus X equals 180. We'll subtract 132, and we get X equals 48. We were hoping it would equal 38 if we had similar triangles, so therefore no, we do not have similar triangles because we only have one pair of congruent angles. Only one pair of congruent angles. Okay, let's look at our next example, or little key vocabulary first. Indirect measurement is a method of using similar triangles to find a missing measure when it is difficult to find it directly. So the key here is we do need to have similar figures. In this case, we'll have some triangles in order for this to work. So we have to prove that they're similar, and then we can use indirect measurement. So let's go ahead and take a look here. So our plan is to cross the river right here, and we need to find X. And to do that, you take measurements on your side of the river. So you measure this distance, and you measure this distance, and you can use these triangles to figure out how far across the river. We're assuming that that is a more difficult measurement to take because it's across the river. So first we need to explain how we know that these two triangles are similar. So we can see that angle B and angle E are right angles. So that's one angle they have in common. Angle B and angle E are 90 degrees. And then we can also see that these two angles are vertical angles. So they must be congruent as well. So we can't just name them both angle C. We need to say BCA and ECD are vertical angles, and they are congruent. Okay, so we're going to use the fact that these are similar triangles to find the distance across the river, and we're going to do that by setting up a proportion. So we need to look to see which angles correspond, which sides and which angles correspond to each other. So if we take this angle and kind of turn it 180 degrees, we can see how those would line up. So this 60-foot side corresponds with X, and this 40-foot side corresponds with the 50-foot side. So there's a couple ways we could set up our proportion. We could say X over 40 equals 60 over 50. We could do 40 over 50 equals X over 60. And then there's a couple other ways to do it too with reversing. But let's go ahead and do X over 40 equals 60 over 50. And then we're going to solve our proportion by setting up an equation using cross products here. So we'll say 50x equals 40 times 60 is 240. We're going to divide both sides by 50, and we get x equals 44 feet. We're going to look back at the problem and see if that seems reasonable. Triangle DEC is smaller than ABC, so we would expect it to be shorter than 60 feet. That seems about right. Go ahead and try a few of these on your own, and I will see you soon.